In this video, I'm just going to answer a question you might see about piecewise functions and how making them continuous. So here's a piecewise function. It's got a linear piece and it's got a quadratic piece. But what's different about this one is the linear piece, they're not telling us what the y-intercept is. The y-intercept is just giving us the value k. So we're asked what value of k would make this function continuous. So let's really kind of roughly sketch this to see what this question is really asking us. Um, so the function which is or the piece which we know what it looks like is this parabola over here, x squared plus 5. So we know it has it has a vertex at 5 and it's a parabola. And this piece applies when x is less than 2. So the value of 2 would be there. Right, so we've got a parabola. So it goes on forever that way, but it stops at 2. And it's less than or equal to, so we get a solid circle. Then we have a line. So a linear equation for the values x bigger than 2. The slope is 2, but we don't know what the y-intercept is. So really the question is, what should the y-intercept be, right? We know we want that the line should meet up with, if it's going to be continuous, we need the line to meet up with this other piece, right? If the line was down here, we had an open circle there, we'd have a jump discontinuity. So we want the line to meet up with the parabola at this value x equals 2. So that's how we're going to answer this question. We're going to say when x equals 2, these two pieces have to meet. So when x equals 2, the two pieces, or the two equations, must be the same, must meet, must be equal. Okay. So what we're going to do is take these two things, 2x plus k, and say that that has to equal x squared plus 5 when x equals 2. So all I have to do is substitute x equals 2 into this equation. So x is equal to 2 plus k. X is equal to 2, so 2 squared plus 5. And then solve for the variable, 2. 2 times 2 is 4 plus k equals 2 squared is 4 plus 5. So we've got 4 plus k equals 9. We'll subtract 9 from both sides. Or sorry, not 9. Subtract 4 from both sides. Right? So these two will cancel. So you get x equals 9 minus 4. And k would equal 5. So k equals 5, meaning the y-intercept here must have been 5. So if I were to continue that right there, so this value here must have been 5 where this line hit the y-intercept. Assuming my slope was appropriate, which it probably wasn't the way I drew it, but that was just a rough sketch, so it doesn't really matter in terms of the sketch. But that's what's happening. So therefore, k equals 5 for f at x to be continuous.